Hello everyone, my name is Fernando Teixeira and I'm a senior instructor at AWS, currently teaching at the AWS Cloud Institute. Today I'm going to talk about designing a serverless AWS application. Now I've been working on a series with hands-on coding for serverless application, but I realized I might have missed a step. Because many of my students will tell me, hey, I understand this application you're showing me, but I don't think I could build one from scratch. And I get that, because if you're a beginner, you might see a tutorial like this, saying, hey, look at this simple architecture for doing a serverless application. And you're gonna say, well, there's nothing simple about that for me. And I understand that. So let's take a quick run through of how I'm gonna go through the drawing board to an architecture. And I'm gonna do that specifically for the travel planning application I'm building on some of my other videos. Now, I know developers like to get coding, myself included sometimes, but it is important to have a vision. Otherwise, you may end up implementing something quick, then you want to add a new feature and you realize that doesn't fit your architecture. My sample application was actually inspired by my background over here because I went on a trip to Iceland and I actually used AI to generate my itinerary. So I figured, hey, how about I create an application that does the same thing? So it may seem unnecessary to write requirements down like this, but it is good to get things organized in your head. And I guarantee you, on a real project, you will have real requirements or use cases, to use the industry term. Now, I'm going to go through each one of those later, but for now, just the big picture, I need to have a web application where I can log in, look at what trips I'm going to, my best trips, create new trips, and yes, the cool part, I want to be able to use AI to generate a sample itinerary for me. So let's look into the architecture for this. Let me start with my overall architectural approach. There are many patterns out there, so I'm just going to discuss two of the best known overall patterns. So first we have the monolithic pattern. It is how most applications were built in the past many years, where all of my functionality is in one place over here. Mind you, in spite of what you might hear, that doesn't necessarily mean a bad design. Yeah, you do have to deploy all of those things together, and which is not as flexible for scalability, but I guess you have a clean design within this box over here. But we now have the microservices approach for the last, I guess 10 years or so. And now you're talking about smaller self-contained services, and they each support a different business function. There is a little bit of complexity in how am I going to integrate those, but they do give me a lot more flexibility in how I deploy them and particularly my ability to scale them. So I'm going to be going with the microservices approach. Let me bring back my requirements because an architecture is only good if it supports your requirements. Starting with the first requirement, I want to use a web application. So just the fact that I want a web application means that I need to select the web framework and decide where I'm going to deploy that application. So I chose the React framework, but honestly, my decision really started with choosing between client-side rendering versus server-side rendering. If you don't know what that is, in client-side rendering, I essentially have right here on my local machine using a JavaScript framework. I create my UI page right here on the client side using some kind of a framework. Examples of that are React, Angular, Ember, Vue. There seems to be another one every day, as opposed to server-side rendering where I need to have a server over here, and that's running some other kind of framework like Django or Spring or Struts. And on the server side, I actually generate that fully built HTML page, and that gets shipped all the way here to the client, which really is kind of dumb in that kind of scenario. Now, I chose a client-side rendering approach. I like it a little better. And within that, I picked React really because it's widely adapted. There's a lot of libraries out there. I could honestly choose another one. Like I said, a new one comes up every day. But one of the nice things about the client-side rendering is that I can now use S3 for my front end because, hey, I don't need a server to generate my HTML and JavaScript. And with S3, I'm going to get that cost-effective, scalable, high availability environment. And yeah, it's a pretty easy choice if I'm going with a static type of web page. Now, it is recommended that if you're using S3 to serve your web pages, you should be using CloudFront, the AWS Content Delivery Network in front of it. CloudFront is going to help you with performance by caching contents closer to your customer, but even more important, it has a lot of security features, including the ability of supporting HTTPS, and S3 alone can't support HTTPS. The next requirement is that I want to log in with my own ID because, of course, users should only be able to see their own trips, right? So I need to select an authentication mechanism. Now, security is super important, and if you're doing everything on your own, you better really know what you're doing and be a security SME, or you can use Amplify to be your SME. Now, I'm using an Amplify library, and with only a few lines of code, I'm gonna get a login page, a user registration that sends me one of those typical email confirmations, and I can even make it fancier if I want to enhance that. Internally, Amplify is going to use Cognito, or Cognito user pool specifically, but I can remain blissfully ignorant of much of that if I want to. Next, I need to be able to view my trips, create new trips, and add itineraries to my trip. So I need to select a database to store that trip data. I selected DynamoDB, but honestly, the first decision was whether I wanted to use a relational versus a non-relational database. And folks, I do have a separate video that really gets into the difference between relationals and non-relational. I'm gonna give you the link for that. So I'm going with DynamoDB, because I like that fact that it's serverless. I love the fact that it's highly scalable and has some awesome performance for well-defined queries. And that well-defined queries is very important. Because if I didn't know the type of queries that I needed, or perhaps I need to pull data from a few different tables and associate them on the fly, yeah, if I needed that, I would likely need a relational database. And RDS has awesome options for that. But in my example, I know my query pattern, so I can take that awesome DynamoDB performance and scalability and go with that. Finally, I have the inspiration for my app. I want to use AI to generate a trip itinerary based on my personal preferences. I don't consider myself an AI expert. Honestly, there's a minuscule number of people out there that can tell you the fine nuances between Claude, Amazon Nova, ChatGPT, and etc. And honestly, new models come up every other day. So I'm going to use Bedrock because I'll be able to pick between a variety of popular models. And even before I pick one and start writing code, I can play around and test them inside Bedrock. And when I'm ready, I can use the Bedrock API to invoke the model. Speaking of invoking, I'll need to write some code to invoke those Bedrock and DynamoDB APIs. So where am I deploying that backend, and what language am I writing that with? Spoiler alert, I'm deploying on Lambda, but there are a number of viable options. I could use a good old EC2 server over here. Frankly, if I need total control of my environment, that's a good option. Perhaps I'm already using a certain OS or machine type, and depending on how many calls I'm getting on Lambda, it could even be more cost effective. But then, I need to control my scaling, and I need to create my load balancer, and I need to handle failover. Now, AWS does have a great support for all of that, but I'll have to plan for it. And EC2 may not be the best fit for a microservice architecture. I could use containers. They are lightweight and they're much easier to scale because, they are lightweight. And AWS does have really good support for them with services like, ECS and EKS. And you can even do serverless with Fargate. So yeah, my containers are gonna be a much better option from architecture, but there's still a bit of container management for me to do and some failover I need to account for. So I landed on Lambda in the end. I don't have any long running functions because remember, a Lambda function can only run for 15 minutes at most. So if I just want to run my beautiful code, it doesn't really get much easier than Lambda. It's gonna handle my scalability and my availability automatically, and it is a great fit for my microservices approach. For my programming language, I went with Python, but I could have gone in any direction. I like Java, JavaScript with Node.js performs really well, and even C++ has a special place in my heart. And AWS has SDKs for all of those and more. I went to Python because it's easy to pick up and my target audience is beginners. And it is widely adopted with extensive libraries available. So it's a good choice in any case. So now I have a front end and a back end. I just need an API layer to connect them. The first decision here is whether I want to use a REST API, GraphQL, or something else more specialized. GraphQL is a nice emerging query language for APIs, and if I had the type of service that is supporting very flexible data operations, it would definitely be worth looking into. But for the very few well-defined calls I need to make, REST will do fine, and it is easy to adopt. And if you're using a REST API in the AWS environment, API Gateway is certainly the way to go. It's simple and intuitive for my API creation. It gives me multiple methods for access control and protection. And it has a wonderful, beautiful native integration with Lambda that if I'm working with Lambda and API Gateway, yeah, it makes it very easy to get them talking to each other. So that takes us to this initial version of this application that I'm building as an example. As I mentioned before, each one of those areas over here, the database, the Bedrock AI models, the Lambda functions, I am covering in separate sessions with code share, detailed hands-on explanations. And if that's not enough for you, one of the nice things about a microservices architecture is that it's flexible to grow. So I'm going to go into lightning round mode right now with some examples. If you want a custom domain like Tucker Travel, well, I can use Route 53 to create and manage that for me. And I can use the AWS Certificate Manager to manage any SSL certificates I might need. Perhaps I have a separate travel agency application over here and I want to forward any trips that got created over there. Well, that's going to be a one-to-one integration and an SQS queue is going to work well for that. But maybe I want to use Kafka, and if I want to use Kafka, well, then I have MSK as a managed service for that. Or if I have to use some kind of a legacy integration over here in this travel agency, well, Amazon MQ will support a lot of older legacy queues. Maybe I'm sleazy and I want to offer a lot of my partners over here the ability to just kind of sit there and listen for any new itineraries created. Well, that's a pub-sub type integration. And SNS, yeah, very nice for that. But I can also use Event Bridge. I can even use DynamoDB streams to basically stream out anything that got inserted to my partners. I don't want to do that. And you know how you get those ads sometimes for shoes and you're going, how am I getting an ad for a shoe just because I was looking at shoes earlier? Well, that's called Clickstream Analytics. And I could get my UI to send any event that's taking place in my application to Kinesis data stream. That then can go to Kinesis Firehose, and Kinesis Firehose can send to Redshift, where I can have some analytics being done after the fact on a ton of data. Or maybe I send it to S3 from Firehose, and then I can create new AI models based on that. As they say, the possibilities are endless, but it's not going to be rapid fire like this. You do need to take it step by step like we saw earlier. This video, on the other hand, is not endless, so that's going to be a wrap over here. Again, the intent wasn't to try to tell you that I could teach you architecture in 20 minutes, but to show that this over here is not magic. If you take it slow, it may not be as daunting as it might seem. So I'll see you around in some of those other more hands-on videos that I'm putting out. Thank you.